A Phoenix-based soil health company has teamed up with ASU to show how Arizona farmers can conserve water through algae. Kathleen Merrigan is the executive director at ASU's Sweetie Center for Sustainable Food Systems. Good to have you here. We used to do a lot of algae stories, it seems like 10, 15 years ago, and then it kind of eased off a little bit. Is algae still a thing?
It's still a thing, a great thing, actually.
Really?
Great to be here. Let's talk.
Let's talk. All right, let's talk about improving soils with algae?
Yeah. So what this company does, that's Phoenix-based, it's called Myland, one word. They extract live native microalgae from a farmer's field, and then they take a close look at it and they figure out what the best strains are. They boost it in a proprietary way, but sort of fermentation, and then they pump it back through the irrigation system that the farmer already has in place to enhance soil quality.
How does it enhance soil quality?
So algae is a biostimulant. There are a lot of biostimulants out there, and farmers are understandably wary because they're all promoted. You know, this is the greatest thing since the beginning of time. And so I actually came across this company when I was working for a venture capital firm based in Europe. And I thought it was very exciting, but the partners at the firm were somewhat skeptical because there was not enough third-party data to support the company's claims. So that was the genesis of this ASU partnership with Myland.
Okay, so we're talking better water efficiency, we're talking better water conservation, we're talking the whole 9 yards here.
Well, microalgae, live microalgae, as Myland puts it into a farmer's system, can do a lot of things, including increasing water holding capacity. And in our very thirsty state, that's very important. But also it will enhance the soil quality generally. But what ASU's project is all about is using state-of-the-art technology to measure the impact on the farmer's water use.
So, and by doing so, you're measuring the impact on the crops themselves, how much they hold. You can do that, how much they additionally hold water now with algae?
What's being held in the soil.
Okay.
So what we do is we go to a farm, and we have several farm sites throughout the state where farmers agree to let us do an experiment there. So we have a control plot and the plot where we're using the Myland solution, and we're collecting real data, a lot of data over time throughout the crops, and a lot of different crops too.
So how is it installed? I mean, do you install it like fertilizer? Do you put it underneath? Is it pumped through? How does it work?
It's great because for the farmer, it's easy peasy. You do have a Myland tank operation that's set up on your farm, but it blends right in with your existing irrigation system. So it's quite easy, actually.
Yeah, and it does make a difference. Again, how much of a difference? Let's say I'm using X amount of water right now. I get Myland, I get all this algae in there. How much am I going to save? X minus what?
Well, that's the question that ASU is working on. So my center, along with the ASU Center for Hydrologic Innovations, is doing measurements on the water with these things called eddy covariance towers, state-of-the-art equipment. And in another few months, we'll have the first reams of data. But Myland does have data on their website that makes claims, but before I speak from the ASU, I'm going to make sure it's all certified, stamped with approval and all of that.
Yeah, you bet. All right, is this the kind of thing that is viable to be mass produced? I mean, in other words, can we see the San Joaquin Valley and all the Midwest with these towers and with this algae being pumped into the ground, or is this kind of a specialized boutique kind of a thing?
It's actually being used in several states now, and I have a bunch of my graduate students this summer. We've been looking at the U.S. Department of Agriculture's EQIP program, Environmental Quality Incentive Program, which helps farmers cost share innovations on their farm that are conservation focused, so saving water, improving soil quality. That potentially could qualify for EQIP. And if it does, then farmers might get as much as 50 to 90% cost share when they implement the technology. So that's a part of our project too.
Last question before you go, real quickly. The quality of the crop, is it as good as it is before? I guess more algae shouldn't make that much difference, should it?
More algae should make a better crop.
It should make a better crop. Better tasting, taller, stronger.
Well, taste is a little subjective, but certainly it will contribute hopefully to yields, but certainly in terms of the resilience in these harsh climates that we face in our climate-stressed world.
Yeah, well, it's very encouraging. Kathleen Merrigan, again, the Sweetie Center for Sustainable Food System. This sounds like a sustainable food system and then some. Thanks for sharing. We appreciate the information.
Thanks for having me.